We have been given a quadratic or a disguised quadratic for cosine here. Now the first thing that strikes me is it's cos 2 theta. So immediately I've just gone and got the trig identities from my formula book here, because I'm going to want to rewrite this cos 2 theta. So cos 2 theta, using this formula book, effectively we're going to have A becomes theta and B becomes theta, and they're added together to give me cos 2 theta. So the first thing to, or the thing to really make sure you do here, is that you include the right symbol, so it's a minus. So we're going to write this one as cos theta minus sine theta sine theta. So that's the same as saying cos squared theta minus sine squared theta. Now, if you've already remembered these identities, then that's brilliant, but this is just what would happen if you'd forgotten them. Now, let's have a look at what we've got here. We've got a quadratic expression in cosine. So ideally, we don't want to be including any sine terms in there, because that's going to make things very, very difficult. So from core 1, or from core 2, sorry, you'll remember sine squared plus cos squared is 1, and we can rewrite that as 1 minus cos squared. So sine squared, sorry, is 1 minus cos squared. So then if we write this out again, I've got cos squared theta minus 1 minus cos squared theta. So this is one of our identities for core 3 really, which is that you've got cos squared minus cos squared, so it's 2 cos squared theta minus the 1. So that's what I can rewrite cos 2 theta as. So then I'm going to rewrite out this quadratic, so it's 3 lots of 2 cos squared theta minus the 1 minus 5 cos theta plus 2 equals 0. And then just tidy this up, so 6 cos squared theta minus the 3 minus 5 cos theta plus 2 equals 0. So the first bit, which is forming the suitable quadratic, is going to be 6 cos squared theta minus 5 cos theta minus 1 equals 0. Now we have to factorise this quadratic. Now I just want to show you how you can do this using your quadratic, using your graphical calculator. So if you already know this, just skip through this little bit. But if you go to part A, your equation solver, you can actually solve a polynomial. So f2, and it's of degree 2 because it's an x squared. And then we're just going to put in minus 5, make sure you've got the signs right, and minus 1. Now, it just saves you a little bit of time, particularly if you're not overly confident with your factorising. So what this tells me is that I can actually go as far as writing theta is equal to 1, or theta is equal to, if you scroll down, it will even give it to you as a fraction, minus 1/6. Now, what the mark scheme says is that you should factorise, but if you have just got to this solution, they will give you 2 marks. So it's a better check. But if you're not confident with factorising, you can't see how this factorises quickly, you don't want to use your quadratic formula because that takes ages, then you could go straight to here to find your 2 solutions for what cos theta is equal to. So this removes the double brackets and all of that stuff. Okay, so I'm down to this stage now. I'm going to now use a different calculator to find my values for cosine. So first thing I'll do is inverse cos of 1. You might not need to do this, but I'll just show you. So that comes to 0. So my first value of theta, let's just show we're going to work here. Theta is equal to 0, or we'll do inverse cosine of the minus a sixth to find the other value. So the other value is 99.594. Now it's after rounding it to the nearest 1 degree, so it's often useful just in the question to go to 1 more degree of accuracy than what it's after. So let's go 59 degrees. Then we just need to find our other solutions in our range. So let's draw our cosine graph out. So it starts at 1, comes down at 90, 270 and 360. So my first solution was when it's equal to 1, which is here, and the second one there is 360. two values there. My second one, remember this point here is 90 degrees. So my second solution is just a little bit further on than that, which means if I draw my line across, I get my other solution there. So that solution can be found by doing 360 minus the 99.59. So that's using the symmetry of that graph. So that comes to 260.41. Now, I've got four solutions here. Checking back with the range, the 0 and the 360 are not included in the range. So neither of those two are going to be my solutions. So my final solutions for my 5 marks are 99.6, sorry. Make sure you get your rounding right, because if you don't do your rounding, you will lose a mark, or 260.4. So as I say, make sure you round them and then you're all finished and that question is done.